Hello, my name is Thijs. I'm the technical evangelist at Varnish Software, and I'd like to welcome you again to another episode of 2-Minute Tech Tuesdays, your weekly appointment for Varnish technology presented to you in 2 minutes or less. This week's episode is about load balancing, which is a concept where loads gets distributed by a load balancer to a collection of underlying servers, using a distribution algorithm to assure equal distribution. So I'm going to explain you how that works in Varnish, and I'll put 2 minutes on the timer already. Ready, set, go. In the case of Varnish, it means Varnish can connect to multiple backends and distribute the backend fetches across using a distribution algorithm. This is controlled by a specific module. It's called VMOD directors. It's in charge of load balancing and installed on every Varnish server. You'll use this for scalability in case of high load on the origin or potential traffic spikes, but also for high availability in case the origin fails. And it's a matter of having enough origin capacity to deal with the following use cases. Potential cache misses on long-tail content. This means content that is not always going to end up being in the cache. Or the impact of uncacheable content, which is even more significant. It's just a matter of not overwhelming the origin, having enough capacity, and the load balancing component will ensure that the load is distributed equally. We tend to use it as well for multi-tier Varnish architectures where one tier connects to the next thanks to intelligent load balancing capabilities. And when planning for failure, load balancers will only select backends that are healthy. So let's talk about the implementation now, and let's leverage the directors VMOD. It all starts when you import the directors VMOD in your VCL file. Of course, you need to predefine the backends you'll load balance through, but in VCL init, you'll have to assign a directors object. You do this through directors dot and then a function, and this function represents the distribution algorithm you'll use. In this case, that's round robin. The backends that you add will be selected based on the distribution algorithm once you call vdir.backend. So in this case, it's round robin. This means first backend 1, then backend 2, and cycling through this. Of course, randomness can be applied as well. So you change the keyword into random and you assign a weight to control the randomness. Here's an example of the fallback director that only is used for high availability. Backend 1 will always be used, and when it fails, backend 2 will be selected. And the final one we'll talk about today is the hashing director, which creates affinity between a specific string value and a backend server, which means every request for this client will end up on the same node. And we can change client IP into request URL. So this means there's an affinity between the request URL and the server. Basically, it could be any string. That was it. That's all the time we have for this week. There's more directors, there's more ways to do load balancing, but I showed you a brief overview. I hope you enjoyed the video. As always, I hope it also provided value. I'll be back next Tuesday with yet another video about Varnish technology presented to you in 2 minutes or less. See you next week.